Have you ever wondered why uterine contractions during labor get closer together over time? Right, like if you sit and think about it, like you might be like, well, I mean, I can kind of understand that the uterus is contracting, right? Something's causing it to contract, but what tells it to contract more, and those contractions to get closer and closer together over time, right? You may have even heard, like, you typically don't go to the hospital until those contractions are around like 5 minutes apart or so. It's kind of an interesting question to think about. Well, the answer, put very simply, is it's called a positive feedback loop. And to help understand this today, we are going to be using one of Kenhub's brand new physiology study units. I'm going to go ahead and scroll to the top, and you can see that this is part of a larger study unit under homeostasis and feedback loops. And again, this is part of our brand new physiology section that we have just launched. We've been working really hard behind the scenes on this. There's so much to this on homeostasis, negative feedback loops, you name it. Right, these are really robust and detailed lessons that you can pretty much understand any physiology program in the entire world. Right, this is not your typical A&P we're talking about. This is like full-blown physiology here. And again, we are slowly releasing these study units over time, so you're going to want to check back frequently to see what we have. But we're going to go ahead and give you a brand new and 100% free study unit for you to check out on your own in physiology. So you can just head down to the description below and you can check that out yourself. But let's figure out what's going on with uterine contractions during labor. And so, like I said, this is all part of what's called a positive feedback loop. And so here's going to be our starting point. And if you look at this, you can see it says the fetus descends in the uterus. And you probably heard, oh, did the baby drop, right? So what will happen is the fetus will drop deeper down into the uterus, and what that is going to do is it's going to put pressure on the cervix. So the cervix is the neck of the uterus. This is what has the opening. It's called the os. That is what's the baby is going to be birthed through. And so you may have heard that the cervix needs to dilate to 10 centimeters. That is true. And then you also need the walls of the cervix to thin out. That is called effacement. And so, as mom is kind of getting ready to have the baby, you'll typically have nurses feeling the uterus, and they can kind of see, oh, okay, we're getting closer. We're at 4 centimeters, 6 centimeters. They can feel how thick it is and get an idea of just how thin that wall is happening. But the point here is, as you put pressure on the cervix, we can then come over here and you can see it says it activates. What's happening is it's activating something called mechanoreceptors. Mechanoreceptors are a type of nerve ending that are going to be all over the body, but in this instance, they're going to be located in the cervix. And what they're doing is they're sending incoming sensory information up to the brain. So we can see in this image, it's going to the spinal cord. That is then going to go up to the brain. And what it's saying is, hey, we're being stretched, right? There's pressure being pushed on here. And so it's communicating with something called the hypothalamus. The hypothalamus is kind of like the bridge between your nervous system and your endocrine system. The nervous system, obviously, like your brain, spinal cord, all that kind of nervous tissue, whereas the endocrine system is all about hormones. And what it does is it communicates to another gland called the pituitary gland. The pituitary gland is what we can see right here. So you can see there's this darker portion, this lighter portion, and just above it, this right here is the hypothalamus. It's just located right above that pituitary gland. And what it's going to do is through that pituitary gland, it is going to release something called oxytocin. Oxytocin is then going to go into the bloodstream, and it's going to intensify uterine contractions. Oxytocin is what's responsible for those labor contractions. Now, oxytocin is an incredible hormone. I could talk for hours. That is not an exaggeration, by the way, about how awesome oxytocin really is. I'll just give you one quick thing. Oxytocin is commonly described as like the love hormone. It's actually not so much about love as much as it's about social bonding and pro-social behavior. It kind of helps us bond together in a really cool time that you and I both can do this. If you actually make eye contact with another person, both oxytocin levels will rise in both people, and you can start to bond with that person. But not only that, if you make eye contact with your dog, the same thing can happen, and you can start to bond more with your dog. It's super interesting. That is like the tip of the iceberg. The point here is oxytocin is an incredible hormone. And what it does in this instance is it again is going to intensify the uterine contractions. And so the uterus is going to start to contract more, right? It's going to intensify. You're going to start to get more sustained contractions. You're going to get them starting to get closer together. And what that's going to do is it's increasing it. That's going to put more pressure on the cervix. And I think you can see where this is going, because as it puts more pressure on the cervix, that is going to activate and stimulate more mechanoreceptors, which are then going to communicate and send that signal to the hypothalamus, which is then going to say, hey, pituitary gland, release more oxytocin, which is going to come here and intensify the uterine contractions, which is going to put more pressure on the cervix, which is going to stimulate. That's a positive feedback loop. Right, a positive feedback loop is, I like to describe this to my students, is like a snowball effect, right? You have that snowball, you start at the top of the hill, and then you put it there and you place it, and it just keeps on rolling and spinning. But obviously, you got to stop at some point, because if you didn't, that would not be good. And so we can see eventually what's going to happen as long as that cervix is dilated enough, as long as it's thinned out enough, and the uterus is able to do those contractions, a baby is born. And when the baby is born, guess what happens? There's no longer any pressure on the cervix. And so we have interrupted that positive feedback loop, and sure enough, it stops. But this is only one type of feedback loop. There's another one called a negative feedback loop, but that is for a different video and a different day. Or you could just go ahead and go to this study unit in our brand new physiology section and learn about it yourself. Again, we're going to go ahead and leave a link down in the description below. And if you enjoyed this video while you're down there, why don't you go ahead and leave a like at the same time. Little things like that go a very long way in helping this video perform better. Please leave us a comment too. Let us know if you enjoyed the video or if there's anything else you just want to discuss. We're always looking forward to see what you have to say. But thanks for hanging out with me. Hope you learned something cool, and I'll see you next time.